Okay, here's how to tell if a bond is polar. Okay, because bond polarity and molecular polarity is actually really different. So we're gonna start off with bond polarity, right? Okay, so bond polarity is basically saying that if the electronegativity is like greater or equal to 0.5, then the bond is polar, right? And to do that, like for example, if we have like H and F, right? Okay, so the electronegativity for hydrogen would be 2.1, right? And then for fluorine, it would be 4.0, because it's the most electronegative and stuff. 4.0 minus 2.1 is 1.9, and 1.9 is greater or equal to 0.5, which means that the bond is polar. But how can we tell that this is also like molecular polarity, right? So to do that, we look at dipole stuff. So with dipoles, there's usually, oh my god, why isn't this working? Okay, wait, there you go. With dipoles, we have like a positive side and then a negative side, right? So this one would be 2.1 electronegativity. This would be 4.0 electronegativity, right? And so this would have a positive dipole, and this would have a negative dipole. Because the more electronegative the element is, the more negative it is, right? Electronegativity is kind of in the name, right? So if there is that dipole thing, right, that dipole difference, then we know that the molecule is also polar. Cool. Okay, let's have another example. Let's do carbon tetrahydride, right? So let's first find out if this is a polar bond. Right? So with bond polarity, again, it's based on electronegativity difference, right? So we know that carbon has electronegativity of 2.5, right? And hydrogen has electronegativity of 2.1. 2.5 minus 2.1 equals 0.4. Is 0.4 greater or equal to 0.5? No. So now we know that the bond is non-polar because there is because it does not have a greater electronegativity than 0.5, right? Okay. Now we need to know if this is a molecular polarity, right? Okay. Molecule polarity. Okay, right? So we know that carbon has an electronegativity of 2.5, but because there's hydrogens all around, this would be 2.1, 2.1, etc., right? We know that there is not really any like dipole movements, right? There's no like dipole. This would be dipole positive dipole, but all around over here it's like negative dipole. See, negative, 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 right? There is no difference over here. There is no difference. Like this is not positive. No, it's just all negative around. And that's essentially like saying there's one happy face, but all around there's sad faces, right? So overall, it's kind of a sad environment, right? Okay. So there's no change around the outer atoms, right? So we know that this is a non-polar molecule. Cool. All right, let's think of something else. How about let's take NH3, right? Okay. NH3. So bond polarity and molecule polarity. Okay. So bond polarity. The electronegativity for nitrogen is 3.0 En, and for hydrogen is 2.1, right? 3.0 minus 2.1 is 0.9, which is greater than equal to 0.5. So we know that this is a polar bond, right? Cool. Now, is this also a polar molecule, right? So over here, we know that nitrogen, with its lone pair of electrons, it is 3.0 En, and this is 2.1, 2.1, 2.1, right? So we know these areas have positive dipole movements, but We also know that this has a negative dipole because it has a higher electronegativity. And we know that these are like opposite poles. These actually have poles, right? That's like saying this is a happy face and then sad face, sad face. But there's still like a happy face. It's not like a sad face and happy face in the middle where everything's just surrounded by sadness, right? It's just there's a happy face too. So it's like part of the poles, right? So we know that because there's different poles, right? And it's not just like one thing that's surrounded like a bunch of things, right? We know that this is a polar molecule. Check. Okay. Cool. Thanks for watching. Have a great day. Bye.